Hey everyone, my name is Ryan Boyd and I'm here at the Neo4j headquarters giving you this webinar to introduce you to Neo4j. This webinar will cover topics that are useful for both business executives as well as engineers, and we hope that you enjoy it. So I'm going to proceed forward here, and we'll have a question and answer period at the end of the webinar should you have any questions. But you can also reach out to me at the email address and Twitter handle that are down below on this slide. To give you some context with where I'm coming from for this presentation, I was a web application developer in an enterprise environment for 5 years. Then I worked at Google for a number of years on our Google Apps and Cloud Platform technologies. And now I'm here at Neo4j and working with a wide variety of different technologies throughout my career. So if you have any questions, feel free to reach out and let me know, and I will be delighted to respond. So let's talk about the origin of databases. Now, data used to be stored on punch tape or punch cards like this. And this was really a horrible way to read and understand data, but it was the best technology that we had at the time, so we used it. And then came along the idea of storing data in tables, in columns and rows. And tables could be human understandable in many cases. As soon as you normalized the data, and created multiple tables and referenced them together by these auto-generated numeric foreign keys, your table might look something like this. Now, the movement around relational databases, around storing data in tables that are interlinked with each other, though, was actually a very strong advance in the technology of databases. In particular, it came along with a property called ACID, which is about enabling atomic transactions that are consistent and provide the durability that you need to really trust your data. So this was an important property that came along with relational databases and something that we've relied upon for many years as an industry. Now, performance was slowed a little bit by this ACID transaction. Of course, not slower than punch tape or punch cards, but the performance is slowed down through this ACID transaction support. But we get around that to some degree by having indexes, which allow you to very quickly look up and retrieve data in your database. Now, a few indexes is okay. Neo4j and graph databases will get there, use indexes as well. But when you have a lot of these tables that are being joined together, and those joins are happening based off of the value of indexes, it gets to be super expensive. We get to the quote-unquote join bomb problem that everyone hates, where they have 10, 20, 30 different tables joined together. Those index lookups make those queries significantly slower. This results in you spending a lot of headache time working with your DBA to optimize your queries or to denormalize your data back in order to enable faster query response time. All right, so SQL databases worked well for a while, but then things got a bit murkier. Things got a bit cloudier. Basically the advent of the cloud, the advent of cloud-based hosting services and storage services, and making the infrastructure part of building applications a lot easier, meant that there was an explosion of data. People started collecting and more data for their applications. And they'd collect it, they'd process it, they'd store it. But at the beginning, at least, you didn't really have the technologies to query that data efficiently, at least querying it in real time. So the internet, the technology industry, everything advanced. And we started to come upon other technologies called NoSQL technologies. But with NoSQL technologies, at least at the beginning, we had to find something that we were willing to have as a trade-off. What were we willing to give up in order to get faster query response times, faster transaction times, etc.? Well, ACID compliance was one of the first things to go. Why do we need ACID compliance in the day and age of the cloud, of the internet, when you have a lot of these applications which are using so much data are things like social networks, where you lose 1 out of every 100 million posts on a social network? Who really cares, unless it was perhaps like the birthday notification for your best friend? You really don't care about losing 1 out of every 100 million transactions. Well, think about it though. What if it was a banking application? We'll talk about that more here shortly. Now, ACID transaction support went away and we got databases that are things like key value stores. Simply put a key and a value, ask for the result or the value of the key, and you get it back. Very, very simple. We also got document databases that allow you to store these large-scale documents, which are fantastic if that's the type of data that you want to store. Similarly with columnar databases. So we advanced with these other NoSQL technologies that allowed us to store different types of data and with different properties for our data. We lost the ACID transaction support, but we gained a lot more scalability. Now, what do we do with the relationships between our data? We talked about relational databases and the join Bob problem. None of these NoSQL technologies really got away from that. These NoSQL technologies still had the concept of having to do joins across multiple different data sets, requiring index lookups and all of that. So what do we do about that? Well, that's where graph databases come along. Graph databases are about taking advantage of the value of the connections between data, because those connections can often be more valuable than the data itself. So this is very important for us to take advantage of. Now, we have this data, the connections between the data. What else do we have in the land of graph databases? Well, especially around Neo4j, we thought ACID transaction support was actually quite important. We brought that back to the world of NoSQL. We added ACID transaction support back so you can trust in your data, because although you might be comfortable losing 1 out of every 100 million Facebook posts, what if that were bank transactions? And what if that 1 out of every 100 million transactions happened to actually be a $1 billion transaction? Well, that would be tragic. You really don't want that to happen. So we think ACID transaction support for a transactional database is really important. That's what makes it a proper database. And Neo4j is a native graph database, which also means that as you traverse the relationships, as you traverse from one node to another node across the relationship, you are simply doing pointer arithmetic in the database. It's super, super fast, and we'll get into that here shortly. Now, what is the impact of connected data? Gartner says that graph analysis is possibly the single most effective competitive differentiator for organizations pursuing data-driven operations and decision. And what organization doesn't want to pursue data-driven operations and decisions? That's pretty much every organization out there nowadays. So consider the impact of graph analysis on your organization as the impact of looking at the connections between data. Connected data is transforming industries. Here's examples of some of our customers. Graph data and connected data transformed some of the major internet players to start with, things like Google with their PageRank algorithm and things like Facebook. But as we get on to some more recent developments, we have folks like LinkedIn. The LinkedIn China group built their social graph on Neo4j. Walmart builds their people and product recommendation engines around Neo4j. And Adidas uses Neo4j to build an understanding of all of their brand assets and the relationships between them. And their location and sports and that sort of thing. So, these are just examples of 3 different companies and their use cases. We'll get into some more here shortly. To introduce Neo4j to you as a company and as a product, well, Neo4j is the world's leading database for connections in data. We power the next generation analytics applications in areas like machine learning, personalized recommendations, fraud detection, and data governance. This is why digital native companies like Medium, eBay, and LinkedIn, as well as companies in transformation like Walmart, Adidas, and Airbus, have chosen to adopt Neo4j. We'll talk a little bit more later about what Airbus is doing with Neo4j. But we have hundreds of successful deployments ranging from both Fortune 500 companies as well as exciting startups. And this is perhaps a good point to mention that Neo4j has multiple editions. We have our community edition as well as an enterprise edition, and we'll talk later about how you decide between them. But I do want to highlight the idea for those startups that are attending today's webinar. I want to highlight the idea that we do have a startup program that allows you to get Neo4j Enterprise at a free or significantly reduced cost. So I'd encourage you to look up the Neo4j startup program and apply to that if you're looking to get started with Neo4j at your startup. I also want to cover here, though, a large number of folks use Neo4j, but we're really proud of where we've gotten in some particular industries. In retail, 7 of the top 10 retailers in the world use Neo4j. In finance, 12 of the top 25 financial services firms use Neo4j. And then in software, 8 of the top 10 software vendors use Neo4j. So we're excited about really the amount of adoption of Neo4j that's out there and really the quality of our customer base. These people have found the value in Neo4j and in connected data. So Neo4j at its heart is a graph platform. It's an internet-scale native graph database which executes connected workloads faster than any other database management system. And this goes along with a mindset about graph thinking. Graph thinking is all about considering connections in data as important as the data itself and how this is reflected in your business. Now, when you use Neo4j and when you adopt Neo4j, you are also joining a huge ecosystem of other companies and partners that have chosen to live in the graph mindset. Now, importantly here, we have 61,000 folks who have trained on Neo4j. We have over 500 partners that can help you with Neo4j, and a couple hundred folks that are actually certified in Neo4j, and you can find those folks on LinkedIn. The community group is huge, and there's also been a lot of software that's been developed and given to the community as open source by various community members. We'll talk about some of that later. So the graph mindset, what is all that about? Well, the whiteboard model is the physical model. And what this means is what a business person, like the gentleman here, will draw up on a whiteboard when they're talking about their business problem is the same thing that is coded by the developer, designed by the architect, stored by the database, in memory, on disk. We are all thinking about graphs in the same structure without any translations in between. It's a much more natural way of thinking about your data. You don't go up to a whiteboard typically and draw tables, columns, rows, foreign key relationships, ER diagrams, etc. But you do go up to your whiteboard and draw what is essentially a graph. So we want to eliminate that translation, and we have for a lot of our customers. So Neo4j as a native graph platform, what does that mean? Well, we have this graph engine that stores all of your data. There's a graph traversal API that sits on top of that. And then there's the Cypher query language. It's a declarative query language optimized for graphs. So it's very similar to SQL, easy to learn, but really optimized for the types of queries that you need to do when your data is in a graph. All of your data is modeled and stored as a graph in the native graph engine. And this means that you have nodes and you have relationships. And you also have properties on those nodes and relationships. And that's why this is called the property graph. And we'll talk about that. Now, a lot of customers are confused by when do you use a relational database, when do you use another NoSQL database, when do you use a graph. You know, we do believe in the concept of polyglot persistence. We believe in choosing the best database for the type of data that you have. And here's some ways to think about it. If you have a relational database, a SQL database, and you're starting to do more than 3 or 4 joins, you're doing 3 or 4 index lookups on each of your queries, well, that's starting to get expensive. So you might want to look at a graph at that point. And then do you look at a native graph database, or do you look at a graph layer on top of another data store? And that's what I want to talk about here. Graph layers are great in that they show that the graph thinking is taking hold in industry. So that part is fantastic. But oftentimes people come to graph databases to get the performance that they need, or that they expect they'll get. And that performance is really only achievable from a native graph database. So if you're doing queries on, or graph-like queries on a non-graph store, you might have something that looks like this. You're doing queries, they're crossing multiple machines, they end up doing multiple index lookups along the way, and your queries end up still being quite expensive. You can think about your data in the form of a graph, which is great, but your queries still lack the performance that you would expect. So that's why with using Neo4j as a native graph database, you can take advantage of the performance features of a graph database due to this property called index-free adjacency. Basically, that means when you are traversing from one node to another node in the graph across a relationship, you're doing that without any index lookups. You're simply doing pointer arithmetic to navigate in memory from one node to the next. And this is really what gives graph databases their performance advantages. So when you're thinking about, do I need graph or not? The answer is probably yes, because you probably have a lot of relationships between your data. And then you're thinking, what type of graph database do I need? Well, think about the properties of a native graph database versus a graph layer. And if you're looking for performance, definitely go with a native graph database like Neo4j. Now, how does the structure of your data affect your organization? Your organization probably has business processes, of course has business processes, and those are stored in an existing data structure. Business processes like hierarchies of your organization, a linear supply chain, and information stored in databases which represent those business hierarchies as you think of them from the restrictions that are put on them by those data structures. It's a little bit of a recursive problem. But what if those data structures that you were storing the data in were actually graphs? That gives you the flexibility to think about your business processes in new ways. Your business hierarchies are really actually graphs. In many cases, people have multiple reporting relationships, and you want to show those relationships, but you can't do that in a strict hierarchy. Similarly, your supply chain is likely not very linear. It's actually multi-related. So one of those suppliers probably has a relationship with another. There are probably subsidiaries within your supplier relationship, etc. And you want to represent all of those connections in order to optimize your business processes. You can do that with a graph. Similarly, your information that you store, you want to talk about the connections between that information. That gives you the knowledge that you need to make sound business decisions. So how do graphs work to connect your data? Now, graphs, any database is really about storage and retrieval. You have these nodes, you have these entities. These entities can get thrown into the database, and then you can pull them back out. But with a graph, as you move your data to a graph, you're thinking about those entities not just of themselves, but the connections between those entities. You're storing that in the graph, and then as you pull it back out, you don't only pull out those nodes, but you also pull out the related nodes, the connections, the data around the data. And this really helps you make smarter decisions, giving you actionable insights from your data that allow you to improve your business processes. Now, you also want to leverage the connections between your data, which today is in various silos. So today you might have a variety of different types of data stores. You have relational databases, document DBs, columnar stores, all sorts of different types of databases. And each of those databases stores a set of data. Well, those sets of data don't need to work just independently. You can take Neo4j and layer Neo4j on top of those data sources to leverage the connections between the data. And so folks oftentimes do this and then have applications that are powered based off of those connections between the data. And then at times they'll move to storing all of the data inside Neo4j, or they might maintain a synchronization process, which can be done between relational databases and Neo4j, or something like Mongo with the Mongo connector and Neo4j, etc. Let's give you a few case studies. In order to talk about these case studies, we should understand the high-level use cases for Neo4j. Oftentimes, Neo4j is used for real-time recommendations, things like recommending products and services, or even recommending news articles like the Financial Times uses it for. Fraud detection, whether it be insurance or other types of financial instruments, or even fraud in gaming industry. All of that can be done and is done in Neo4j. Network and IT operations. Networks are graphs. Graphs are networks. So it's important to do your analysis, to do your root cause analysis or your dependency analysis within a graph database. You can also take advantage of graph-based search as you're searching the data throughout your organization and your master data management, thinking about the suppliers and thinking about the employees and thinking about the customers and the relationships between all of them. And lastly, think about identity and access management. You think about how a user gets authorized to access a system on your network or a set of data on your network. Now, typical systems will look at like LDAP directories for that, but LDAP enforces a strict tree hierarchy. The real world, as we've seen, isn't really a strict tree hierarchy. It is a graph. So customers of Neo4j have used Neo4j to perform in real time these access decisions. They also use Neo4j to audit their directory environments, things like Active Directory, and understand where the loopholes are in those environments, particularly around the group memberships. So these are the types of customers that are using us for these various use cases. Now I want to talk about NASA. So NASA is also a Neo4j user, and NASA built a knowledge graph of all the lessons learned from all of the NASA's prior missions. David Meza, the chief knowledge architect at NASA, spearheaded this project, and he was looking to go beyond the type of keyword search that they had in the past and really understand the relationships between all of these projects and the mistakes that happened in the past to learn from that for future projects. And an engineer working on the Orion mission found information from the Apollo project using Neo4j, which prevented an issue and saved well over 2 years worth of work and $1 million of taxpayer funds. Now, how can you get started with Neo4j? Well, there's a basic process here to working with Neo4j, and that is creating the model of your data, loading your data into Neo4j, and then querying it. Sounds pretty simple. Let's go through some of that. Creating the model. So you model your data in Neo4j using the property graph. So in this case, we have 2 nodes. We have Anne and we have Dan, and we want to represent that Anne loves Dan. So we're going to do that by creating these nodes using the Cypher query language you talked about. And you can see the create statement here in the slide. First of all, we are saying create, then we're saying the label, basically the type of node that we're creating, in this case a person node. And then we're setting a variety of properties, in this case only one, saying the name of that person is Anne. And then we're drawing the relationship using this ASCII art syntax, basically drawing the arrow using the dash and the greater than symbol here to say that that person named Anne loves another person named Dan. And when you execute this statement, it will actually create both of those nodes as well as a relationship between those nodes in the underlying database. Now you see here how you can have properties on your nodes. You can also have properties on your relationships. So for instance, we have Anne loves Dan. We could have on the loves relationship, we could have the date, for instance, that Anne started loving Dan, or how much she loves Dan. We could have all that on the relationship. Now Neo4j allows you to store directed relationships. So in this case here, we're saying Anne loves Dan. We don't know if vice versa is also true. If we do know that Dan loves Anne, we can create a relationship in that direction as well. And when you search your data, you can actually search regardless of the direction of the relationship. All right, so querying data. The first place that people start querying data with Neo4j is in the Neo4j browser. This is a web-based interactive tool for exploring your data and writing your Cypher queries so that then you can include those queries in your application code. This is a tool designed for developers. It is an interface that uses terminology and the overall UX for developers. If you're looking for a BI tool or something for end users to investigate data, we do have a number of different partners which produce such tools, one of which is called Linkurious, and you can check those folks out if you're looking to build front ends for your users. But for now, we're talking about the developer interface in the Neo4j browser. Of course, Neo4j isn't designed to just query in a web interface. It's also designed specifically to query within code. You want to be able to write application code which queries your Neo4j database and makes decisions in real time based off of the graph. Now you can do this from a variety of different programming languages. We offer official language drivers in JavaScript, Java, Python, and .NET and Python. And these are only just our official drivers that Neo4j produces, maintains, and supports. But there's a variety of other community language drivers out there as well. Ruby, Haskell, Go, PHP, and many other languages and frameworks have drivers for them. So I'd encourage you to check out those different drivers, check out the driver for the language of your choice, and start playing with Neo4j. You can also extend Neo4j though. You don't just need to write these Cypher queries, which are sent via the drivers from your favorite programming language. You can also write Java code that is embedded in the database and executed as user-defined procedures and functions. This Java code running directly in the database can do any sort of graph traversals that you want to do in a sort of procedural or imperative fashion. You can look at writing your own user-defined procedures and functions, but you can also look at the APOC library. This is a huge library of hundreds of stored procedures and functions which allow you to do a variety of different things like run graph algorithms, import data from a variety of different data sources, interact with date and time objects, run some queries on the overall structure of your graph, all sorts of different functionality. So I'd encourage you to check out the APOC library if you're serious about Neo4j. Now, I oftentimes like to include quotes in the presentations from well-known users like the David Meza quote that you saw earlier, someone who is from a famous institution like NASA. In this case, the quote is from someone who I personally don't recognize their name, but he said, "I can't believe that Neo4j is actually real. Seems like a dream come true." It's truly validating for the team here at Neo4j who builds this database. And you'll find a lot of our users to be that excited about Neo4j. We have dozens or hundreds of quotes like this from the community, raving about everything from the Cypher query language to the quality of the browser and more. Now I'm going to jump in to the Neo4j Sandbox here. The Neo4j Sandbox is something that I personally built working with a variety of my colleagues to get content and guides. And basically it's a way for you to easily get started with Neo4j for whatever use case you desire. And it comes with these interactive guides and data sets for that use case that makes it really easy to get going. So I'm going to actually show that to you here today. And I do want to mention that the Neo4j Sandbox runs on Neo4j Enterprise Edition and also includes all of the APOC libraries that we just talked about. You do get some smaller instances with the Sandbox. We don't allocate too much memory or CPU, but it's still a great way to play around with Neo4j. So I'm going to hop over here to my web browser, and this is the Sandbox at neo4j.com/sandbox. And we're going to say we want to log in. And when we log in, we're going to be prompted to log in with a variety of different identity providers, either your Google account or your LinkedIn account, Twitter, GitHub. You can also create your own username and password if you want. But I'm going to log in with my Google account here. And then we can see that I'm given the option to launch a new sandbox. And I can launch sandboxes for a variety of different use cases. There's recommendations. How do you build recommendation engines on top of Neo4j? Using the standard built-in graph functionality as well as some graph algorithms to make your recommendations even more accurate. Then there's the network and IT management sandbox. And the network and IT management sandbox allows you to do dependency and root cause analysis that we talked about earlier. I'm going to launch the recommendation sandbox, but I can also talk about some of the others. There's Legisgraph, which is the US Congress, the relationship between the members of Congress and the bills and votes that they've done. Panama Papers by the International Consortium of Investigative Journalists, and a spreadsheets grapher that allows you to take data from your own Google Spreadsheets or Google Drive account and put that into the graph database really easily. But we launched earlier this recommendation engine, and you can see a couple different tabs here across the top. We have Get Started, then we have Details, the Data Model, Code, and Advanced. So let me talk about two things. One is code. With the code, you get tabs for each of the popular programming languages. And this is copy and pastable code that even includes the credentials for accessing your sandbox in the cloud. So you can run these code samples from your local machine and see how to write code in these languages to call a Neo4j database. We also do have the data model, which is what the data is that we're working on. In the case of the recommendation sandbox, we're looking at directors and actors and genres of movies, as well as users who rated those movies and how those ratings work out in order to provide recommendations. I also want to show you a new feature of the sandbox, which is the ability to share a sandbox with another user, either a friend or someone else, a colleague in your organization. So I encourage you all to share your sandboxes. This will actually share the sandbox instance, which includes the database and all the underlying data. So if you make some changes to the database, your friends or colleagues can see those changes. But I wanted to hop in here pretty quickly into the Neo4j browser. And this is the Neo4j browser that we talked about earlier. It's loaded up already with a database of movie data with a variety of different relationships. And we can see more information. Like I said, we're using the Neo4j Enterprise Edition, version 3.2.2 in this case here. And you should definitely tour around the browser, play around, look at how you can bookmark queries, look at how you can get quick access to the documentation or the Cypher ref card. And there's some more great functionality here. But to talk about the guide and recommendations, we actually have this interactive guide which guides you through how you build recommendations. It starts off with showing you what the property graph model is, reviewing some of the material that I covered earlier in this webinar, nodes and labels and relationships and properties. It also talks about Cypher and shows you how Cypher works and dissects one of these statements here. In this case, this statement is looking to find users who rated a movie where the title contains matrix, and we want to get the title as well as the count of reviews because there were multiple matrix movies. And we can see here that there are 259 reviews for the first Matrix, The Matrix, 82 for The Matrix Reloaded, and then 54 for The Matrix Revolutions. So it'll provide example queries here that you can just click on and execute, and those are fantastic. And then it will also give you the topic area and teach you a little bit about recommendations in this case. The two types of recommendations, content-based filtering or collaborative filtering. So for instance, this one is finding products similar to the product you're looking at now. So for instance, if you're looking at the movie The Net, what movies are similar to The Net based off of genre or who acted in it or who directed in it, up to 2 degrees out in the graph. So that's a fun query that shows the very graphy results. And we can see here is The Net. We have Sandra Bullock acted in the movie The Net, and also the other movies that she acted in. We can see the other movies that her co-actors acted in. Dennis Miller acted in Murder at 1600, for instance. All sorts of great data that we can see from a very simple graphy query. And then you can look, for instance, at users who bought something and also bought another thing. So for instance, we can say, we're saying bought. In this case, we're actually using ratings. So a user rated the movie Crimson Tide. What other movies did that user rate? And you can see that the most popular other movie that a user rated was Forrest Gump, along then with Dances with Wolves, Pulp Fiction, etc. So those are simple recommendation queries that you can make, and you can think about these recommendations not only as recommendations for content but also recommendations for purchasing things, recommendations for objects to buy in games and things like that, or retail. As I mentioned, a large number of the top retailers use Neo4j. So this next one's a little bit more complex of a query, but we're looking for content recommendation based off of overlapping genres. So we have a user, Angelica Rodriguez, rated movies. That movie was in a genre. Let's find other movies in that genre where the user has not rated those other movies. And you can see here with the Cypher query language how easy it is to read and understand what's going on here. Whereas if you had an equivalent equivalent SQL statement and you were looking at all the joins, it would be much more difficult to read if you did not have experience using it. So anyway, that shows you some of the recommendations and the recommendations guide. There's plenty more material here. Our CEO was super excited that he saw mathematical formulas in this guide. Some of the other guides aren't quite as scientific from that perspective, but Will here went really far and did, for instance, here the most similar users by using cosine similarity and getting a result there. So you can run some algorithms on this data, either very similar algorithms to what you've already used in other data sources or graph-specific algorithms like clustering algorithms and that sort of thing, community detection. But that gives you an overview of the Neo4j sandbox. One of the particular sandboxes. Encourage you to visit, again, neo4j.com/sandbox and check out some of the other sandboxes which may be of interest to you. Okay, so we're back in the presentation here. Let's talk a little bit about your options for your architecture. How do you integrate Neo4j with your enterprise architecture? Well, you have your applications that are trying to make real-time decisions on your data. Those applications probably interact with a variety of different data sources, relational databases, other NoSQL databases, using Hadoop infrastructure as an example. And those applications can also use a Neo4j cluster. We do believe in the concept of polyglot persistence. If you have tabular data, store it in a tabular database, store it in a relational SQL database. If you have columnar data, store it in a columnar data store. If you have documents, you can store it in a document data store. But you'll find increasingly, as you look at the power of understanding the relationships between your data, you're going to want to store more and more data in a native graph database like Neo4j. This shows a cluster of machines. The Neo4j Enterprise Edition supports causal clustering, which allows you to have high scalability and also failover in the case of disasters. So if you're running a serious business application, you'll want to use the Neo4j Enterprise Edition to get that capability. And we'll talk about more of the capabilities here shortly. But your application can interact with all of these different data sources, Neo4j, other NoSQL, relational, Hadoop. And then your data scientists and your analytic architecture can integrate with those data sources as well to produce reports and other things much faster than you had done in the past. Oftentimes you can do these reports in real time versus sort of the batch processes that you may be accustomed to. So a lot of users migrate from a relational database to a graph in one form or the other. So RDBMS to graph, how are they doing their migrations? Some folks are migrating all of their data. They are choosing to move their key transactional data store over to Neo4j, which is fantastic. Other folks are migrating a subset of their data and then performing the graph-like queries on the graph-like data in the graph database, the non-graph queries on the relational database, and their application combines those results for any sort of displays or actions it needs to take. Other folks duplicate a subset of their data. They duplicate the data from their relational database and duplicate the data also into their graph database, and then let application developers decide, based off of the types of queries they want to perform, where is the best place to query the data. Now, I did say I would talk to you about Community and Enterprise. These are the two editions of Neo4j. Both editions are open source, although the Enterprise edition, for you to use it for commercial purposes, requires that you purchase a license from Neo4j. So we license that commercially. We have a help desk team, support team, we have field engineers, we have all of the infrastructure around a commercial database product that you would expect. We even have professional services as well as partners who do system integration and that sort of thing. So you can choose between these two editions. When do you use which? Well, the answer is actually pretty clear, and the answer is outlined on our website when you go to download it. If you're an individual, you can use the Community Edition. If you're playing around with data, you don't care about disaster recovery and backups and the performance characteristics that you might get from the Enterprise Edition, that's fine. If you are a business that are seriously investing in graph, you should definitely look at getting Enterprise Edition licensing. And the Enterprise Edition is available for a 30-day free trial, but you can also get access to the Enterprise Edition on the Sandbox. And the Enterprise Edition provides additional functionality for management, things like backups. It provides some greater data integrity constraints, user management, and a lot of the things that your operations professionals need to have to run a serious database, like clustering architectures that you can even do multi-data center clustering around the world. So if you are a serious business building applications that are mission critical on top of Neo4j, definitely go for the Enterprise, try out the 30-day trial, and go forth. So hopefully that answers your question about the difference between those two. But as you're in your learning path, discovering Neo4j, I wanted to give you an idea of what's next for you. Next, I would suggest that you do check out the Neo4j Sandbox, neo4j.com/sandbox, and you play around with some of the various different data sets. Whether they be data sets that are just for fun, looking at the Panama Papers, for instance, or looking at some of the movies data, or looking at our Graph Connect schedules or things like that, or whether they be data sets that are for serious business, like the recommendations data set and guides, or the network and IT operations. Definitely encourage you to check out the Sandbox as your next step. Then you might want to look at the online training and in-person classroom trainings that we offer. You can go to neo4j.com/Graph Academy and check out the training opportunities. And you may want to then eventually get yourself certified. And the Neo4j certification program will allow you to show to your current employer as well as to potential future employers your expertise in graph database technology. And if you're truly interested in graphs, I recommend that you join me and the rest of the Neo4j community and the Neo4j engineers at our Graph Connect conference, October 23rd and 24th. This year it is moved to New York City, so I'd encourage you to join us there. The first day is an executive summit as well as training classes. So the full day training classes that we offer traditionally around the world, as well as workshops on a variety of different topics, including modern topics like GraphQL and Neo4j, or some of the data science technologies and how you use those with Neo4j. The second day, October 24th, is our main conference. That's where we have keynotes by our CEO and our chief scientist. and dozens of other talks by our community, as well as our customers, partners, and other folks, both full-length talks as well as 15-minute lightning talks. If you like that sort of thing, I'd encourage you to attend Graph Connect and learn from all of that, and just socialize with us, get help with your graph modeling from Neo4j engineers, participate in the hackathon, and really dive deep into understanding the world of graphs. So with that, I'd like to say thank you, and you can reach out to me at RYGuyRG. I gave you my email address, ryan@neo4j.com earlier. You can also reach my whole team at devrel@neo4j.com. In particular, if I'm on vacation, then maybe someone else will answer that email. So I encourage you to reach out with any questions that you have, and thank you very much for attending the webinar.